right now. Okay, we've dealt with distance, which is one-dimensional, right? That's distance. We've dealt with area, which is two-dimensional. But now we're going to start to add the third dimension. So the word that we use for measuring things in 3 dimensions is volume. Okay? So just like this bottle, which is basically a cylinder for the most part, has a volume. Anything that is 3-dimensional. This pen is also a cylinder. It has a volume. Anything in 3 dimensions is measured in, pay attention, volume. It's not acceptable. Pay attention. You're famous now. The next thing it has is the lateral area. So the lateral area is the area of all the sides around a prism. So if you guys think back to the hexagonal prism, I just want to show you really quickly what I'm talking about. You guys remember this figure here?
Yeah.
Yeah? Is that familiar?
Yeah.
Yeah.
The first level one.
First level one, right. Everybody remember this? This is a hexagonal prism. So, no. It's okay to say no, although it's kind of sad too, because we did a lot of it. The lateral area is all the walls. It's the area of all the walls around it. The next one you get is the surface area. The surface area will be the area of all the walls plus the top and the bottom, which we call the bases. So I want you to notice, bases here is capital. So this is not like the base of a triangle. And that's why we have to be paying attention. So the top here, that's a base. How many bases does this prism have? 2, the top and the bottom. All prisms have 2 bases. Okay? And the last thing I want to get out there is a net. A net is a 2-dimensional. What does 2-dimensional mean?
Something that's not 3D.
Okay, but what does it look like?
Flat.
Flat, right. So it's a 2-dimensional representation of a prism. So a 2-dimensional representation of this would take the 2 hexagons and put them like this. And the other one could be over here. And then the rest would be this rectangle. You see how that works? The rectangle folds around it. This is what this would look like. So this would be a net of hexagonal prism. It's been unfolded. Okay? So what we have here are nets. So, good questions. What would this look like if we folded it up?
Triangle.
So if this is a hexagonal prism, what's this one going to be?
Triangle.
Triangular prism. There we go. So basically the 2 bases are this triangle and this triangle. Does that make sense? And in your nets, what you're going to notice is that the things hanging out to the sides will be considered the bases. And the lateral area, or the walls, will be the rectangle down the middle. Okay, so in this case, this is a base, and this is a base. Now if you look back at your warm-up, how wide is this?
3.
3? And how long is this?
4.
4. Is this a right triangle?
Yeah.
Can we do the Pythagorean theorem?
It's 5.
So you solved it and this was 5, right? There we go. And how long was this?
5.
5, which makes sense because when you fold it,
It has to add up.
they're going to line up, aren't they? Can you picture that in your head?
No.
Okay, how long was this?
3.
3. How long was this?
3.
3.
3.
3.
3.
3.
4.
No.
5.
5.
4.
4.
5.
5.
3.
3. Okay, so if we wanted to find the perimeter, of course, we would just add all this up, right? So 3 plus 3 is 6, plus 3 is 9, plus 5 is 14, plus 5 is 19, plus 3 is 22, 27, 32, 35, 38. 38 what? Units, because it's a perimeter. Perimeter is distance. Distance is one-dimensional. Now, if we're finding the area of this, what we're really doing is finding the entire surface area of a triangular prism. Okay, the lateral area would be the area of this. Does that make sense? The surface area is the walls plus the 2 bases. Okay? So if we're doing the full area, we're doing all of this. So first of all, let's just do it in sections. That's the smartest way to do it. Here we have a triangle. What's the base of this triangle?
3.
3. What's the height?
4.
4, so it's base times height divided by 2. So 12 divided by 2 is what? 6. So this one is 6. What about this one? 3 by 3, it's a rectangle.
9 divided by 2.
Oh, why are we dividing by 2?
Never mind.
Just 9, right? Okay, good. And then this one, 3 times 4 divided by 2?
6.
6 again. This one is 3 times 4, so it's what?
12.
12, good. This one is 3 times 5?
15.
15. So if you want to find the entire surface area of this prism, 9 plus 6 plus 12 plus 6 plus 15. So that's going to be 6 plus 12 plus 6 is 24, plus 15 is 39, plus 8 is 48. So it's 48 what? Units squared. Okay? So that area is the full surface area. Surface area is the entire figure. If we're doing the lateral area, that's pretty easy. The lateral area is just the walls. So 15 plus 12 is 27, plus 9 is 38. All right, no. Sorry, 36 units squared. Because it's 15 plus 12 plus 9. So that would be the lateral area. You guys getting the idea here?
Yeah.
Okay. All right, so of course if you were to fold it up, it would make something like this. And it's usually a good idea to kind of make your base shape the thing that's facing you. And basically what we've got is this. Can you guys all visualize how that folds into this shape here?
Yeah.
Yeah, not too hard? Okay, so let's label it just to be clear. How long is this?
4.
4. Remember to get that this is this. How long is this side?
5.
5, good. How long is this side? 3.
3.
And here?
3.
3, good. Okay, the last thing we need to know is the volume. The volume, again, is the amount of three-dimensional space. So will volume be in units, units squared, or something else?
Units cubed.
Units cubed, because it's three-dimensional, that's right. So what we do is we take the area of the main shape. So what is the area of the main shape?
3 more.
3 times 4 divided by 2, because it's a triangle, right? So what was the area of the main
6.
shape? 6. Okay, so the volume is going to be equal to the area of the main shape times the distance between the two bases. So how far is it from this base to the back base?
3.
3. So it's this times this. What do we get? 18 units
Cube.
cubed. Correct.
Big number. That doesn't count as area though, right?
No, that's not the area. That's the volume. Okay, so we've got the perimeter of the net, we've got the surface area, we've got the lateral area, and we've got the volume. Now we're working all the way up through level 2 right now, so don't be intimidated. Level 1 is mainly identifying the net. So speaking of identifying the net, what type of figure do you think this one will make?
Cube.
Cube is correct. Good. So how long is this distance here?
3.
3. And this one?
3.
Is it 3 everywhere?
Yes.
How long is this?
6.
6. Okay.
3.
3.
3.
3.
3. 3.
3.
3. 6. 3.
Okay. So if we want to find the perimeter, of course, we'll just add it all up, right? 3, 6, 9, 12, 18.
Why don't you just do 3
20.
times 14?
Hmm?
Why don't you do 3 times 14?
Because it has 14 sides?
Yeah.
Sounds fine. 3 times 14 is 42.
42.
As long as you're correct. Yeah, that works. That's fine. Good. Okay, the area. Well, how many of these squares are there?
6.
Are they all congruent?
Yeah.
Yep. And what's the area of one of them?
9.
9.
9. So just 9 times 1, 2, 3, 4, 5, 6. It's going to equal
54.
54 what?
Units squared.
Cube. Oh, squared.
Squared, because the area. Okay. Now that area, is that the surface area or the lateral area?
Surface area.
Surface area, because it includes the two bases. Okay? So basically, get this idea. In your nets, the wings, the things sticking out to the side, those will be the bases, okay? And the ones down the middle will be the walls. Does that make sense?
Right.
So if you have your bases and your walls, the lateral area is just the area of the walls. So how many of these squares make up the lateral area here?
4.
4, so it's just going to be 4 times 9. So the surface area was 54, the lateral area will be 4 times 9.
20. Oh.
34.
4 times 9, boys and girls. 36 what?
Units.
Units squared. Good. And lastly, when we fold it up, what's it going to make?
A cube.
A cube. How do we know it's actually a cube? Are these all congruent squares? Are they all 3 by 3? So the definition of a cube is that they're all exactly the same. So a cube looks like this. And it's going to be like this. Does that make sense to everybody?
Yeah.
Okay. So if you want to do the volume, well, what's the area of the front of it?
9.
9. So we'll make that one of the bases. What's the area of the back of it?
9.
9, right? So it's this times the distance between them. How far is it from the front to the back?
9 times 3.
3. So 9 times 3 is going to be what?
27.
So it's going to be 27
Units cubed.
units cubed. Okay, that's an introduction to lateral area, surface area, and volume with nets. It's a lot of business, but I think practice is what it really takes. So follow along, watch the video multiple times, and practice on your homework. Thank you.